Alrighty, so in these notes here, we are going to talk about triangles. So buckle your seatbelts, everyone. Triangles we have so many things we're going to be doing with triangles, you just don't even know. So first, we're just going to start it out with some of the essential things to know about triangles. So a triangle is the union of three segments joining three non-collinear points. Remember, non-collinear means they're not on the same line. A segment of a triangle. So the segments of a triangle are the sides, and their endpoints are the vertices. So if we were to draw a triangle here, right? So this here, the bigger circles I have are the endpoints, and this is going to be a side. And there are three sides to a triangle. Next, triangles can be classified by the number of congruent sides and by the size of their angles. Okay, so here we have, when we classify them by their angles, so essentially what that means is I'm going to give you a triangle and there's going to be degrees within them and you have to say whether it's a specific triangle or not based on what you see. So an acute triangle is when all sides are acute. So the degree of the angles are all greater than 0 or less than 90. So 0 or greater than 90. Sorry, less, but I can't talk. Greater than 0, but less than 90. Okay, then we have an obtuse triangle. So obtuse is when at least we have one of its angles are obtuse. So one angle is obtuse. So if I were to draw a triangle, it would look something like this, where this angle would be an obtuse angle. Let's say this is 100 degrees. Okay? Then we have a right triangle. A right triangle looks like this here with just a right angle. It's a triangle with a right angle. One of its angles is right. And then this next one is a tongue twister. It's called an equiangular. So this is when all of its angles are congruent. All the angles are congruent. Next, we're going to talk about triangles classified by their sides. So the first one we have here is scalene. Scalene is when none of its sides are congruent. Okay, so none of the sides are congruent. So let's say we have a triangle here. This is going to be, let's do this here. Let's say we have a 3, 4, 6. Okay, so 3, 4, 6, this triangle here is, all the sides are different. They're not the same, so we have a scalene triangle. The next is an isosceles. So this is when at least two of the triangle sides are congruent. Okay, so at least two of them. Here's the notation for it, right? Two sides just congruent with a tick mark. This one here, I sometimes call the isosceles triangle angry triangle because it just looks like an angry face. Next, we have the equilateral triangle. That's when all of the sides are congruent. All right, so let's moving on to the next page here. So this next one is going to be about a proof. So we're going to do a proof about how the sum of the measures of the angles in a triangle are 180 degrees. Okay, so here, everything that you do can be done by a proof. And quite frankly, everything was done by a proof for you to be able to do it all. So here we are given a triangle. We want to prove that the measure of angle 1, 2, and 3 equals 180 degrees. So the first few steps in here, one is the given, right? Yes, that's the given. In step 2, this one says draw line XY through B so that XY and AC are parallel. So we've got these two here are parallel. I'm going to erase these here. And so this is from the parallel postulate. We've done this before. It's a parallel postulate where we can draw a point, or we're given a point and a line. And through that point, there's exactly one line that'll make these two lines parallel. Okay, so that's what that one's saying. Next, we have here angle 4 and angle ABY. Angle 4 and angle ABY are supplementary. So a linear pair implies supplementary angles, right? They're on the line. And then next we have, in the next step, angle 4 plus the measure of angle ABY equals 180. Of course, from here, the supplementary angle, bring that to the if statement. So if it's supplementary angles, the sum is 180 degrees. Next, we can go ahead and say, all right, well, let's take a look at the measure of angle ABY. or let's look at ABY. So ABY is this big angle here. It is made up of 3 and 5. So the measure of angle 5 plus the measure of angle 3 will equal the entire angle, right? And that's angle addition postulate. Next, we're going to do substitution, right? So the next step is substitution. So bear with me here. So we have the measure of angle ABY. That equals all of this stuff, okay? In this step here, step 4, we have the measure of angle ABY. We're going to take this stuff and plug it into there. When we plug it into there, we end up having measure of angle 4 plus the measure of angle 5, measure of angle 3, and that will equal 180. Next, what we have here is angle 4 and angle 1 are congruent, and angle 2 and angle 5 are congruent. Parallel lines imply alternate interior angles congruent. So let's take a look here. We know that we have parallel lines because XY and AC. So here, angle 4 and 1, totally alternate interior angles. And then we have here angle 5 and angle 2. So then from here, we are going to then say, since these are congruent, we can then write them to be equal to each other. Okay, so congruent angles implies equal measure, equal angle measure. And then next is substitution. So the substitution here, we have this lovely equation here. We know that angle 4 equals angle 1. We know angle 5 equals angle 2. So wherever we have a 4, we're going to plug in the 1. And when we have the 5, we're going to plug in the 2. And that's where we get our final step to say that the measure of angle 1 plus the measure of angle 2 equals 180. Okay, so next here we're going to talk about the exterior angle. So exterior angle. So an exterior angle of a triangle, remember exterior is the outside. So the exterior angle of a triangle that forms a linear pair with an angle that lies inside a triangle, okay? The other two angles, so the other two angles of the triangle are called remote interior to that exterior angle. So let's go ahead and let's take a look at an example here. So we have here this triangle inside of these lines. So I'm going to highlight that triangle. And so take a notice that's we have an angle 7, 8, and a 9. Okay, so that's the interior. Alrighty, so then everything else is on the exterior. Okay, so we have here angle 1. Angle 1 is the exterior angle. Angle 1 is on the outside. So remember, it has to be the exterior angle is of the triangle that is formed by a linear pair. So here, this is the line that angle 1 is on, and then 9 and 1 are a linear pair. So then the remote interior angles will be 7 and 8. It's the two other angles. So we have angle 7 and 8. All right, next we have angle 2. So taking a look at angle 2. Oh my goodness, I keep deleting everything. So angle 2 here, this is the linear, well, that's the line. So then angle 8 and 2 are linear pair. Since we know those two are a linear pair, the opposite angles from that way, the other two angles are going to be the remote interior. So we have 7 and 9. And then angle 3 here, 3, the line we have here is going this way. So then the linear pair is going to be 3 and 8. So then the other angles are 7 and 9. All right, so if you want to go ahead and pause this video and then go ahead and fill out the rest of these on your own, and then when you push play, they will all be filled in. Alrighty, so here we are with the next little bit. So then the rest of them are going to be as follows. So going off of this, please note that angle 10, 11, and 12 are not exterior angles. They are the vertical angles, okay? So they are vertical angles to the triangle. Instead, they have to be linear paired to be able to be the exterior angles to the triangle. So here I have highlighted in green angle 10, 11, and 12 so you get the visual of where they are located. All right, next we are going to go ahead and do our final problem here. We have this proof. This proof, what it is saying is, so the measure of an exterior angle of a triangle equals the sum of the measure of its two remote interior angles. Okay, so for example, let's say that this is 100 degrees. Okay, if that is 100 degrees, and let's say this angle here is 30 degrees. Okay, the measure of angle 2, we know because we can do the measure of angle 4 plus equals the measure of angle 2 plus the measure of angle 3. The measure of angle 4 is 100 equals the measure of angle 2, since we don't know what it is, plus 30. We'll subtract 30, right, and we get 70 degrees. So that's what it's saying here. Now, that's not always going to be congruent, right, because here we have 30 and 70. Sometimes it might be the case, sometimes it won't be. Okay, so here's the proof that walks you through it. So we are given angle 4 is an exterior angle. So angle 4 is an exterior, it's on the outside. Okay, so that's the given. Next, we have here angle 1 and 4 are supplementary, right? That's a linear pair. And again, supplementary angles. So linear pair implies supplementary angles. Supplementary angles, we can go ahead and add the two angles and set it equal to 180. Then we know that we have our triangles. We know, we just proved it on the last page, triangles, when we add up all the angles, it equals 180. So a triangle implies the sum of the angles equals 180. Next, we could do substitution or transitive, whichever way your brain is interpreting it. So both of these are equal to 180. So that's where we can take this here and this guy here. Oops, wrong one. Plug that into there and this over here and set them equal. And then from there we can solve. So we can subtract the measure of angle 1 minus the measure of angle 1. Those cancel, right? Because it's the subtraction property. And then we finally get what we are looking for. The measure of angle 4 equals the measure of angle 2 plus the measure of angle 3. Next and finally, we are going to talk about these two little corollaries right here. So acute angles, so the acute angles of a right triangle are complementary. So what that means is when we have a right triangle, okay, this right triangle, that degree is 90 degrees. Let's say this one is 30 degrees and this one is 60 degrees. When we take these two angles, we add the acute angles, 30 plus 60, it will equal 90 degrees, which is complementary. The next one is saying that in any triangle, there is at most one right or one obtuse angle. Okay, so this one here, so a triangle at most one right angle or one obtuse angle. That's just saying that when you have a right triangle, only one angle can be a right angle. When you have an obtuse triangle, you can only have one angle that's going to be obtuse. The rest of them would be acute. Okay, so the rest of the angles would be acute. That's the obtuse. Okay, and that is it.